How's it going, everybody? And welcome back to our Enterprise Practice Lab. In this video, we're going to be going through and setting up ISP1, getting it all operational, OSPF, BGP, all the cool stuff, and getting all that squared away. And go from there. So, without any further ado, let's go ahead and dive into our config. I'm going to go ahead and get out of the way. So we're going to form OSPF adjacency, OSPF area 0 between devices and ISP1, fairly simple config, and then form iBGP peerings from CSR 28, which will be a BGP route reflector to the other ISP devices. Then we're going to need to redistribute BGP into OSPF for route propagation, because by default, they're not going to propagate. You need to learn who's going to be advertising routes, where and how the underlay is going to be connected and all that type of stuff. Then form iBGP peerings to ISP2 and ISP3, and then form iBGP peerings to customer devices. Fairly straightforward config. Let's go ahead and get into the config itself. So we're going to be on 16. Oh, I got to scoot to my left here. CSR 16, right there. So I'm going to go to the global config here. I'm going to do router OSPF 1. Router ID is going to be, in this case here, it's going to be 1.0.0.16. And then I'm going to go to network statement of anything, in this case here, 1.0.0.0, 0.255.255.255, area 0. But I'm going to type in passive interface is going to be, I'm going to say gig 3, because I don't want to accidentally form an OSPF adjacency out this link right here. So this link I will go ahead and make passive. So there's that. I'm going to go ahead and jump over to CSR 28, which is way over here. Same thing. I'm going to go ahead and do a router OSPF 1. Router ID will be 1.0.0.28, and we'll do a network statement of 1.0.0.0, 0.255.255.255, area 0. And then now that that's in play, should be good to go there. And now I'm going to go over to XR 17 and 18 and get them configured. So there's our adjacency. If I do show IP route, we're going to learn some routes in. We'll learn, the route that we'll learn in is going to be the 116. We're going to learn the subnet, right? But we're not actually going to form an adjacency over it. 116 being the connection between CSR 16 and down to the internet link that the Palo firewalls are terminating. So I'm going to go on to XR 17. I'm going to log in as Rob and Cisco. I'm going to go to global config. I'm going to type in router OSPF 1. Router ID is going to be 1.0.0.17, and I'm going to type in interface gig area 0, interface, in this case here, gig 00000 and gig 1, and then I'm going to go ahead and commit that. And I'm going to do the same thing. Actually, let me do one other thing. I'm going to exit out of here and exit out of here and type in log adjacency changes, log neighbor, log adjacency changes, and then I'm going to do exit out of here and type in logging con debug, commit that. So on 18, I'm going to go do the same thing. So I'm going to log in Rob and Cisco, go to, Rob and Cisco, go to global config, logging con debug, router OSPF 1. We're going to type in router ID of 1.0.0.18. We're going to say area 0, interface gig 0/0/0 and gig 1, and commit, and log adjacency changes and commit. So there we go. We have adjacencies to 28 and 17. Show IP route. Do show IP route. All right, so we have connectivity between all the devices. So 16, 1, 28. So I actually need to go and area 0, interface loopback 0, commit. Do that as well on 17. So router OSPF 1, area 0, interface loopback 0. Go ahead and add that in real quick. That's where I'm going to source my connections from. So we're using ASN 1. I'm going to go ahead and CSR 28, which is over here. I'm going to go ahead and do show IP route. I need to make sure that I have connectivity from OSPF. I can talk to 16, 17, and 18. So 16, 17, and 18, I have them in my OSPF routing tables, or it's in the routing table as OSPF learned routes. So now I got to go to router BGP, in this case here 1, and I'm going to type in no BGP default IPv4. But what I am going to do is I'm going to use a peer template, and simply for the fact that I don't want to do repetitive config over and over again per peering. Just imagine if you've got 1,000 of these devices, you're going to create one template, or you could have many different templates, but you're going to pick and choose the templates that you want to create and map per the peering types that you're going to be doing. So I'm going to type in peer template. There's the peer session, which is the IPv4 unicast peering, and then you have the peer policy, which is going to be applying address family specific configuration. So the peer session, we're going to name it, we're just going to say session. And underneath here, we're going to type in here remote AS is going to be 1, update source is going to be loopback 0. And if we want to do other things like TTL security or timers or any other capability, because there's a lot of options we have underneath here, we could set that up. Now, the other thing I'm going to do is do the template peer policy, and we're going to call this policy. And on here, we're going to say route reflector client, and then I'm also going to say soft reconfiguration inbound, and then that's going to allow me to see routes coming in and being advertised. So what routes have I received? So normally at a really big deployment, you probably wouldn't want to do that, because if you have thousands of routes, that could be more memory on the device than you necessarily need, because it's going to chew up extra memory on the device to capture all the routes that have been received versus what the routes have been sent. So you can do advertised routes, which is an unpacking of the BGP update table, the table itself, on a per address family basis. And then you have software configuration inbound is a capturing of receive routes. So you can see what somebody else sent you before you go to the BGP table inbound. And that's where all the route policy, so your any prefix list filtering, any route filters, period, any routes that go through the BGP best path selection algorithm, anything that doesn't make it past that adjacency rib in, I believe, is the process that comes in. Once it hits that, you're not going to see everything in the BGP table. So you're basically saying, I want to save in memory everything I'm receiving from somebody else, take that inbound, and then I can see what I'm receiving, and then compare that to the BGP table and say, oh yes, the routes that you did advertise to me, I am either I'm not learning it, or I am learning it, and maybe some policy attribute that it's getting applied, stuff like that. So now that I've got that done, I get to go ahead and go neighbor, and it's going to be 1.0.0.16, and here I would say inherit, and I'm going to say peer session, and do the same thing with 17 and 18. Just like that. And then I would type in address family IPv4 unicast. I hit the up arrow a couple times, and I type in activate for these peerings. And then I would say go back to here and type in inherit peer policy. across the board. 17 and then 18. Now what that does, if I do show run pipe section BGP, you're going to get, instead of me having to retype these commands per neighbor statement and reapply these entries per neighbor statement underneath the address family, I apply it once per neighbor at the session level and at the policy level, and then it applies these variables accordingly. Now the cool thing is, this is a route reflector design. So what I'm going to be able to go do now is on 16, 17, and 18, all I have to do is go to router BGP 1 and type in neighbor of 1.0.0.28 remote AS of 1 and say update source loopback 0, and then address family IPv4 unicast, and then activate the peering. That's it. Oh, I didn't turn the no BGP default IPv4 off. So do show IP BGP summary. I have an active adjacency. So I'm going to go ahead and save that. I'm going to go to 17. 17 is very similar. Let me go ahead and type in root so I get out of OSPF. Router BGP 1, no BGP default IPv4, not a command, right? So no BGP default local preference. So there is no capability of automatically forming IPv4 unicast peerings with BGP in XR. You have to define it per address family. So what I have to do underneath here is type in address family IPv4 unicast and go from there. Now what I get to go do is type in neighbor, and I can do underneath here, I can do neighbor group, session group, or an address family group. So a neighbor would be just that. You have a neighbor and then you have your address family. Session's a little bit different. If I say session group, I say, you know, name, we'll say session, right? And I go underneath here, I would have remote AS, update source, stuff like that. But if I went and did neighbor dash group and say neighbor, and went underneath here, it's going to be basically the same thing. A little bit more, but for the most part the same thing. So session and neighbor, to me, there's you don't get everything, but there's probably some overlap here, and I don't honestly know the key differences between the two. But I'm going to go ahead and exit out of here, and then I'm going to type in session address family, and then sorry, it's going to be AF group. That's right, AF group, AFI, and then underneath address. Oh, so you have the IPv4 unicast, and then you have to go underneath here. This is where you do your route reflector client, any of your other variables that you want to deal with. So I'm actually going to go ahead and get out of here. Show config, and I'm just going to type in no all these out because I don't need them there. Just to show you that those options are there. Just like that. I'm just going to type in neighbor, and it's going to be 1.0.0.28. Type in remote AS of 1, update source, loopback, update dash source, loopback 0, address family, IPv4 unicast, and that's really it. Hit the up arrow a couple times, and then I'm going to do a show config, and then I can basically copy and take this config right here, and I can commit. Actually, let me back up one level here. Yeah, that's fine. BGP router ID is going to be 1.0.0.17. And I'm going to go ahead and commit that config, and then jump over to 18 and do the same thing. So root router BGP 1, router ID is going to be 1.0.0.18. We're going to say that address family, and I can just go ahead and paste it in the config as you can see here. And then I'm going to go ahead and just commit it. So 28 should perform a peering here as well. And there it is, it's up. So if I go to 28 again and I hit the up arrow, I look at it, do a show BGP IPv4 unicast summary, I'm learning routes. Or I'm sorry, I have BGP peerings. This is, and again, this is not the same thing as advertising routes. I've literally just brought the control plane up. I still have to advertise routes and how I'm going to do that. So that's all looking good. If I do a show IP route though, you'll notice that I haven't learned anything, right? So what I'm going to go do is on CSR 28, since I'm on this box already, I'm going to go ahead and I'm going to take this subnet right here, 13.19.28. So router BGP 1, address family IPv4 unicast. I'm going to type in network of 13.19.28.0 mask of /24. I have to use the mask command because this is a class A address range, so it would automatically put it as a /28, or sorry, /8. Now that I've done that, if I go over here to CSR 16 and I hit the up arrow, I'm learning a route, and you can see the next hop is 1.0.0.28. If I do show IP route, I can see the route in my routing table, and it's an iBGP route, right? So that's working the way we expect it to. Now on CSR 16, if I go to CSR 28 and I do show IP, we can see this route here is learned via OSPF 1.16, but I want to learn that via BGP though. So what I'm going to do is on CSR 16, I'm going to go ahead and underneath the address family where I'm already at, I can type in redistribute connected, and I'm going to say route dash map, and I'm going to say BGP connected, and then hit the enter key. Now it creates the route map, or I'm sorry, defines the redistribution, but the route map doesn't exist yet. So I'm going to type in route dash map BGP connected, and I'm going to type in match interface gig 3. And then when I do that, if I do a show BGP IPv4 unicast, I'll see that, well, it might not be triggering it. Might take it a couple seconds for it to trigger. Do show BGP IPv4 unicast. I should be learning that in here momentarily. So one thing we could do on 16 is I could do a clear BGP IPv4 unicast star soft. It may not work with the match interface. Show route map. That might not work the way I want it to. Oh, there it is. Okay. So it just took longer than I anticipated. So we can see that it's advertising the route. Next hop is me, right? And the question mark means that it was redistributed. It doesn't know the sources. So if I go to 28 now, and I hit the up arrow, I can see it, and notice that the next hop is 1.0.0.16. Works out great. So that's going to be the next piece we need to have into play. So now we've got that. I'm going to take the XR18 and do the exact same thing. But to do redistribution or any type of connectivity outbound, well, there's some fanciness that I need to do on the XRV boxes. So on router BGP 1, underneath address family IPv4 unicast, I'm going to go ahead and type in network of 13.18.29.0/24. And I'm just going to commit that. So now CSR 28 should learn that. And it's going to take some time to do clear BGP IPv4 unicast star soft. Now the route is being learned via 18, and 16 should learn that because we've got route reflection. Now if I hit the up arrow and I look at this specific route, it should show that it's coming from it's 28. It doesn't show that it's telling me that it's actually no 28, wrong box, 29. B network not in table yet. Oh, sorry, I meant to say 18. So I'm getting it from 28, but it's actually being sent to me from 18. 18 being XRV 18. Now last but certainly not least is going to be XR 17. Do show BGP IPv4 unicast. We can see those routes coming through. Everything looks pretty good. As long as you have the appropriate next hop, you're in good shape. Okay, so now that we have that in play, the next stage in the process here would be to do the same thing. I'm going to go ahead and create a route policy on XR so that we can redistribute gig 2 and gig 3 essentially in. So route dash policy, and I'm going to call this BGP connected. And then underneath here, we're going to say it's a set, if, and set. So I'm going to say set, and I should be able to do, I don't think I can do interfaces here. Yeah, I'm not going to be able to do interfaces here. So there's a couple different ways that you can do this. I can go if, well, let me do interface here. It's been a minute since I've done this. I don't remember what actually is available. Okay, so normally I would do a tag, but what I'm going to do instead, let me go ahead and exit out of here. I'm going to create a prefix set. Not the same thing as a prefix list. I'm going to say if prefix set is X, go ahead and allow it. So I'm going to type in prefix set. I'm going to call connected. And underneath here, I need to say what the subnet is. In this case here, scoot this over just a touch. The subnet, actually I can just do a do show IP interface brief. Do show IP interface brief. And I'm going to have 17 on, what is that, gig 2. So gig 2 is going to be, we're going to say 1.17.31.0/24, and then we're going to do a comma, and we're going to do 12.17.39.0/24. I'm going to go ahead and exit. That closes the prefix set. So show run pipe section prefix set. Is section not supported? Begin prefix dash set. Show config. That's right. So the config is right here. So now I'm going to type in the route policy. I'm going to say if the I'm going to say, actually no, it's going to be set. No, I have to match first. It's going to be if the source in member of a set in connected, there we go, if it is in connected. It's been, like I said, it's been a minute since I've done this, so I have to remember what the syntax is for XR. So I'm going to hit the enter key there. Then you would go ahead and say, so then we can hit the enter key here. Then we can say pass. And that's really all we need to do. And then we're going to say end if. And then I'm going to be able to do a show config. Actually, let me exit the RPL. Show config. And what I'm saying is we have the prefix set connected for the two subnets that we want to advertise, right? If I want to, and I'm 99% sure that's what I want. Correct, it is. Let me go bring this back up here. So I'm going to go ahead and create a route policy that says BGP connected. If the source is in connected, so which it is, pass. End if, meaning I don't have any other policies to match on, go ahead and just pass. I'm going to go ahead and I'm going to commit that config. And then I'm going to go to show run, do show run, router BGP. So now I'm going to go underneath router BGP 1, address family, IPv4 unicast. I'm going to type in redistribute, connected. Actually, I can do connected, but I want to match on route policy of BGP connected. Because I don't want to do all of them, right? I want to just do a specific set of subnets that I want to advertise into BGP. So now that I've done that, show config, that's the syntax. I'm going to go ahead and commit. And okay, so we got a problem with there. So it's there's a pseudo atomic issue. Show config failed. It's telling me that could not find entry in list policy BGP connected. There is no source attribute in the BGP redistribution filter attach point. Do show run RPL. Thought I commit. Yeah, I connected it. You know what? I'm just gonna bug out on this, and I'm gonna say abort. Go back to global config, router BGP 1, and then network address family IPv4 unicast, and type in network of 12.17.39.0/24 and network of 1.17.31.0/24, and I'm going to go ahead and commit those just so that we can get the config in play. So everybody should be learning that now. XRB18 do show BGP IPv4 unicast. We should start to see those routes being learned. So do clear BGP IPv4 unicast *soft. Might take it a minute for it to propagate. There they are. Now 18 should see them. There we go. And we can see that 17 is advertising both. Okay, now that we have that in play, the next stage of the game is to form peering. So what I've got now, so part of this, we can set up the peerings ahead of time. So OSPF 2, or BGP, sorry, ISP 2 will be this one right here. So I'm going to go ahead and get that one started because it's pretty easy to do. So I'm going to go ahead, that's the end of this video. Once we have all three of the connections online, we'll be able to go ahead and do the iBGP peerings between them and start doing the route propagation. So that is pretty much it for this video. This is one of those things where you have to get the ISPs stood up first, and then you can do all of the connections downstream to the remote connections to the other ISPs, and then do the customer peerings to it, and then that'll come online. So at this point in time, we're in good shape. We've gotten everything peered the way we need it to. There's some stuff that I did kind of off the cuff, but obviously, if this was the lab, I'd be much more crisp on how I would do route advertisement. More often than not, I'm going to tag an interface. I'm going to give it a tag value so that if I need to tag multiple interfaces, or I would just use a network statement. It depends on the situation at hand. So it depends. And normally I'm not trying to advertise. I don't usually do service provider work. So you're normally not trying to advertise tons and tons of routes at one time. But if you are, tagging is a great way to do that. Because then you can, especially when it comes to like VXLAN EVPN, for example. Because on all the SPIs, I gave it a tag value, did a route map match on that tag, and then redistributed direct and matching on the route map. So it redistributed both SPI subnets into it. It's a very common design. So with that being said, I'm going to go ahead and we're going to get ISP2 up and running, and then once we get ISP2 up and running, we'll get ISP3, get that all squared away. That'll take a little bit of time, and then we'll be able to get the iBGP peering up. So one question that I know is going to be asked, because of the way that I'm kind of deviating exactly the way everything is set up on a per task basis, you're not required in the lab exam to do everything in an ordered fashion, because there might be dependencies. Especially in the config section of the lab, there's a lot of interdependencies. Interdependency simply means that you need one thing is reliant on another thing to work. So if I need all of the ISPs operational before I can go through and get everything configured, and that's something I need to go do. The name of the game when you're talking about a lab like this is there's probably going to be some things that you're going to skip over, like the customer devices. I'm not doing that yet. I want to have all of my ISP connectivity in place first. Once that's there, then I can go ahead and jump into doing inter-ISP connectivity to do full route propagation, and then I can do all of my connections down to the customer devices. Once I have that in play, I can do full route propagation, and if I am missing if there's an issue in any type of route propagation, or for example, any of my ISPs have an additional connection or something that's not getting advertised somewhere, that would be the time I would dig into it and figure out, okay, why is this not working? So now is really not the time to try to troubleshoot that, because for this ISP, everything's working. Like I see route advertisement and things are going across. However, when we do eBGP, that might not be the case. I might not get a route from this route here, might not show up over here for whatever reason. And then I had to troubleshoot that and figure out why is it not getting propagated. So that's where, once you have the main connectivity up, and you're trying to go through and make sure end-to-end connectivity is in place, that's why knowing how to deal with that is important. So with that being said, I want to thank you guys for stopping by and hanging out, and I'll catch everybody in the next video.